Hello, today we're going to learn about dictionaries. We briefly learned about dictionaries in the previous class. Today we're going to learn in detail about the dictionary type. A dictionary is a data structure of key-value pairs that store the value with a key as an index. The key must be unique and the type of key must be immutable. Let's look at an example in the slide. A key undergrads stores a value of 10, a key grads stores a value of 5, and a key faculty stores a value of 2. A dictionary can be initialized using curly braces. When storing one key value pair, you can write the key to the left of the colon and the value to the right of the colon. Each item is separated by a comma. An empty dictionary can be created using curly braces. If you want to add a new item to any dictionary, put the key value in square brackets as follows, and assign the value to the location of the key. An empty dictionary can also be created using the function dict. A dictionary in Python cannot have multiple keys with the same value. If a key exists in a dictionary, adding a new value to the dictionary simply changes the value connected to that key. For example, when the value associated with the key faculty is 2, assigning 10 as the value of the faculty key will change the value of faculty to 10. If you know the key, you can access the value associated with that key. For example, if you want to know the value associated with the grads key in the dictionary mydict, you can access the value as shown in the slide. Just like accessing elements using square brackets and an index in string, list, tuple, when accessing any value among items in the dictionary, just put the key in square brackets. As explained earlier, to update the value associated with a key, simply assign a new value. Dictionary can be printed using the print function, and by using the len function, you can know the length of the dictionary, which is the number of the items in the dictionary. Let's assume you run a small market. If you want to store each product and its inventory in a dictionary, how can you make a given list into a dictionary? For example, we could implement a function called getMarketDict like this. In this function, after receiving the inventory list, set the key value as a string in the list, and initialize all the inventory value to 1. However, this function works normally only when there is one item per product. In other words, this function does not work properly in a situation where there are multiple stocks of one product in the list. For example, let's say your inventory list looks like the following list. If you look at the list, there are 2 bananas. In this case, we can use the in keyword to check whether dictionary contains a particular key. As shown in the slide, assuming that an item string is in a variable called item, the expression item in MarketDict returns true if the value of item exists as a key in MarketDict. If the value of item does not exist in MarketDict, false is returned. Let's modify the code using this expression. If the item string exists as a key in the dictionary already, we add 1 to the value of the item key. If not, we can store the string of the product as the new key and set the value to 1. In addition to conditional statements, we can modify the function by utilizing the get method of the dictionary. The get method receives a key and a default value as arguments, and if the key argument value does not exist in the dictionary, this function returns the default value given as an argument. For example, as shown in the slide, if the key value students does not exist in the dictionary myDict, the code myDict.get student0 returns 0. We can change the getMarketDict function implemented earlier by using the get method as follows. If any product string does not exist in MarketDict, the get method returns 0, and the value of the string key is eventually assigned to 1. Otherwise, the currently stored value is returned from the method and incremented by 1 and stored as a new value of the key in the dictionary. In a dictionary, each item is a key and the value pair. However, if you run the code in the slide, you can see that only the keys, not the key value pair of the dictionary, are assigned one by one to the variable existing between for and in. The for key in A statement shown in the slide means that the keys existing in a dictionary named A are assigned to the variable key during the iteration. Therefore, the program prints the key first and prints the value corresponding to the key. A dictionary has various methods. For example, the keys method returns all key values in a dictionary in the form of a sequence. For example, all keys of the dictionary called animals on the slide can be obtained by using the keys method as follows. This return value can be traversed using a for loop or can be cast to a list. Similarly, you can use the values method to get the values that exist as values in a dictionary. The return value is a sequence type that can be traversed through a for loop, and it can also be cast to a list. All the data in the dictionary can also be obtained into a sequence using the items method. We can use a for loop to get the key and value pairs of any dictionary as tuple type values one by one. However, the types of return values of keys, values, and items method are different from the list type. Therefore, if you want to use these return values like a list, you must cast the return values of these methods using the list function. The hasKey method returns true when an argument exists as a key in the dictionary. For example, in the dictionary named PersonDict, shown in the slide, the string key value age exists, so PersonDict.hasKeyAge returns true. If you want to remove a key value pair from a dictionary, you can use the del keyword. For example, when del PersonDict name in the slide is executed, the key, name, and its value John will be removed from the PersonDict variable. If you pass any dictionary as an argument to the list function, guess what value will be returned? If we run the program shown in the previous slide, we can see that only the keys of dictionary A exist in the variable A list. If so, how can we convert key and value pairs of a dictionary into a list? Earlier, we learned that by using the items method, we can convert any dictionary into a sequence of items. However, since this type is different from list, if we put it as an argument to the list function, we can return a list consisting of tuples of keys and values. A dictionary can be used as an argument to various built-in functions. For example, if you pass a dictionary as an argument to the max function, this function returns the largest value among the keys in the dictionary. And if we pass a dictionary as an argument to the min function, this function returns the smallest value among the keys in the dictionary. If you pass a dictionary as an argument to the sum function, this function returns the sum of the keys in the dictionary. As mentioned earlier, the keys of a dictionary must be of an immutable data type. Thus, a tuple can be a key in a dictionary, but a list cannot be a key in a dictionary. You may be wondering if there is a case where a tuple is used as a key. Let's say we create a dictionary with latitude and longitude values as keys and city names as values. In this case, we need to know both latitude and longitude values to know the city that exists at that location. We can set latitude-longitude tuple as a key in this situation. If we run the program shown in the slide, we can find out which city exists at a coordinate by making a coordinate tuple as a key. What if, from a dictionary, you want to create a dictionary in which key and value are reversed? This time, using the knowledge you have learned so far, try implementing a function called reverseDict that returns a dictionary whose keys and values are reversed when the dictionary is passed to the parameter originalDict. Stop the lecture video, try to implement it yourself, and then play the lecture again. For example, we can implement the reverseDict function by utilizing the items method as follows. First, we initialize a dictionary called newDict that the function will return, and assign the key and value pairs to a variable called item one by one using the for statement and items method. And inside the for statement, the key and value are reversed and stored in newDict. When the iteration ends, the function returns a newDict. To test whether this function works, create a dictionary called A, pass A as an argument to the reverseDict function, assign the return value to a variable B, and print it. Looking at the printed result, we can see that the function is implemented as we want it to. Dictionary is a mutable data type. Therefore, it is also possible to change the value associated with the key in the dictionary, or to add new keys and values to the dictionary. And when a dictionary is passed as an argument to any function, the original data address is assigned to the parameter, and the parameter inside the function refers to the address of the original. Therefore, it is possible to change the argument dictionary even inside the function. Since a dictionary is a mutable data type like a list, when a dictionary variable is assigned to another variable, the two variables refer to the same address. For example, if you run the code in the slide, you can see that the value of his muffins connected to the blueberry key has changed, even though the variable his muffins has not been changed. This is because my muffins has changed. In Python, assigning a mutable variable to another variable is called aliasing. And in this case, the two variables share the same value address. If we want to copy the values of a dictionary and create a new dictionary in another space, we can use the dictionary's method copy. A dictionary's copy method returns a new dictionary of values equal to the original dictionary. For example, the code mymuffins.copy returns a new dictionary with the same data as the dictionary mymuffins. Therefore, the hisMuffins variable gets the return value of this function refers to a new dictionary stored in another data space. And even if mymuffins is changed afterwards, the value of hisMuffins does not change. Conversely, even if hisMuffins is changed, the value of mymuffins does not change. Let's solve a practice problem. When a certain natural number is given as an argument to the parameter num of a function, try implementing a function getDigitDictNum that returns the number of occurrences of the numbers in each digit of the natural number in the form of a dictionary. For example, we can implement the function like this. First, initialize a dictionary called returnDict, which the function will return. And as long as the num variable is greater than or equal to 0, the iteration continues. If the remainder of num divided by 10 exists in returnDict as a key, increment the value of the key by 1. If the remainder after dividing num by 10 does not exist in returnDict as a key, the remainder is set as key and the value connected to the key is set as 1. Then divide num by 10 and continue the iteration. After the iteration ends, returnDict is returned. To test whether this function works normally, pass the number in the slide to the getDigitDict function as an argument and print the return value. If we check the printed result, we can see that in the number in the slide, the number 9 appears once, 1 appears 3 times, 4 appears 5 times, 7 appears twice, 6 appears 3 times, 3 appears once, and 2 appears once. For those who have trouble understanding this function, I will show you how returnDict changes after the function is called. First, the last digit of num is 9. However, 9 does not exist as a key value after returnDict is initialized. Thus, the else statement is executed. After that, a key of 9 and the value of 1 are added to returnDict as one item. After that, the num is divided by 10 and the quotient is reassigned to num and the iteration goes on again. The last digit of num becomes 1, so the conditional expression is evaluated again. At this time, 1 becomes the remainder of dividing num by 10, and since 1 also does not exist as key of returnDict, the else statement is executed, and the value of 1 is connected to key 1. The quotient of num divided by 10 is reassigned to num, and the iteration continues. Now, the last digit of num becomes 4, the remainder becomes 4. 4 is added as the key of returnDict, and 1 is stored as the value corresponding to the key. Again, the quotient of num divided by 10 is stored in num, and the iteration continues. Now, the last digit of num becomes 1. After the conditional expression is checked, 1 already exists as a key in returnDict. So the if condition becomes true, and the value corresponding to key 1 in return dict increases by 1. If the iteration proceeds in this way, 0 is eventually assigned to num, and the iteration ends. Eventually, through this loop, we can store the number of occurrences of the digits in the num and return dict. This is the end of today's lecture. Next time, we will learn about modules.